Welcome to the Able Skills Basic Plumbing tutorial from our series of DVD tutorials. In this DVD, you will be taught the various stages and techniques involved in basic plumbing, allowing you to prepare and join pipework and everything you need to know to fit a full bathroom suite. Once complete, you will be able to take on a wide range of plumbing jobs with confidence. For this section, you will need a 15mm pipe cutter, a 22mm pipe cutter, a set of pipe benders, and a 90-degree set square, all of which are available from your local plumber's merchant. Before you begin, you will need to prepare your pipework and choose the suitable pipes for the job you are tackling. Copper pipes are used for all plumbing jobs where the pipes are not on show. An example would be where pipes run under floors and behind walls. Copper pipes are hard-wearing and joints are soldered, ensuring good, strong connections throughout. Whatever project you're tackling, your pipes have to be cut to suit the workspace. You will need to use the pipe cutter for a 15mm pipe. For our demonstration, we are using one with an opening point at the top. It simply opens up, you slot the pipe in between, line the blade up where you want to cut, and close the top. Holding the pipe firmly, grip the cutters and turn in the direction indicated. As well as cutting pipes, to be able to fit tight spaces and lay out pipe runs around obstacles, we must bend the copper pipes. When bending pipes, you will need a set of benders. You can get standard 15mm benders, but the ones we're demonstrating are a combination model capable of bending 15mm and 22mm. There is a stop at the back, the roller, and formers. Included is a guide. This one is a 15mm guide, and there is also a 22mm guide available. When you are using the benders, there is a gap at this point here. If you keep that gap parallel with the roller, the benders are fully open. If you open them too much, you cannot operate the stop. Always lay the benders down, keeping the gap and the handle on the right-hand side, so we can apply the power to the right-hand side. There are two methods for pipe bending. One is precision bending, and the other is estimated bending. With precision bending, you need a set start point. For the demonstration, we will use this end for the set start point. Measure down 200mm and then mark the pipe with a nice clear line. We're going to bend this pipe 90 degrees, so slot the pipe in, bring up the stop. The guide will fit in, curly side towards the pipe and the flat side towards the roller. All benders have a slack built in, so you must taper the slack by closing the benders slightly. By doing this, the pipe will be held firmly in place. The point where we drew the line is where we want to bend 90 degrees. The 90-degree mark needs to be perfectly level with the outside of the former, and that will give us 200mm from the fixed point to the back of the pipe, where the pipe bends round. The pipe sits perfectly in the former, and the back edge is in line. Using your set square, line it up on the edge of the former. You need the line to be in perfect alignment with the edge of that square. Pick up the benders, apply power with your right hand, keeping an eye on the measurement. Take power off the bender and slacken slightly. You will see that the standing end has not moved, and the running end has been bent. So line your set square up on the standing end and check against the running end to make sure it is 90 degrees. Check the measurement by taking the pipe out of the bender, lining up the set square on the back of the pipe, and you should get a 200mm measurement. It works exactly the same the other way around. Sometimes you will need to put more than one bend in, but it has to go in a different direction, so the same principles apply. We will now add another bend to this pipe. It will have the same measurements as the other bend. Measure 200mm from the straight edge and mark the pipe. We must measure from the bend, so this end must go into the top of the bender, and we want the pipe to go the other way. Now, if you've noticed, we've applied pressure with the right hand. So we've moved the pipe to the left. We're now going to move this to the right, to turn it upside down like that, exactly the same as before. We have to check that we have a 90-degree plane across the pipeline and the former, which is in line there. Use a set square to check the alignment. You may need to move the pipe slightly if it's not in line with the pencil line. Once happy that this is all in line, pull it round and lay the bender down. This is now our standing end because it hasn't moved. Use a set square again to check that the pipe is bent 90 degrees. Practice this if you feel you need to. If you bend the pipes the wrong way, it's not the end of the world. You can cut the pipe and solder the cut end onto the other end, using a straight connector. If you find this method difficult, then you can use estimated bending. To do this, we will use an estimated measurement from the top of the pipe, which is slightly larger than between the gap and the hole in the wall. The end you measure from must always go in the top of the bender. Use your plumber's eye to get an approximate 90-degree bend, and then use your set square to check that it is a 90-degree angle. The copper pipes to be used for hot and cold water feed are 15mm and 22mm. These are for the hot and cold feed in. You can get the equivalent in plastic, but it's more expensive, and copper will stand the test of time. The bath waste pipe is 1.5 inch 40mm plastic. For the basin you use 1.25 inch 32mm plastic. 1.5 inch is also used for kitchen sinks and for shell basins. For this section you'll require a roll of lead-free solder, a pot of flux, a propane-powered blowtorch, a roll of PTFE tape, and a 15mm and 22mm pipe cleaner or some wire wool. In this section we will show you the different types of pipe joints and the methods in which these can be applied. All the parts shown are available from a local plumber's merchant. The first thing we will cover is end feed capillary fittings. And they're called end feed because you must add solder to the end of the joint once you've cleaned it. These are the cheapest version available, which means there is a lot more work, as you have to clean all the joining surfaces, add the flux, add the solder, and the heat. These are available in different sizes, the main ones being elbow, T-piece, (15mm) T-piece between 22mm, and various shapes and sizes, working your way up. The next one up from an end feed is a solder ring fitting, also sometimes known as a Yorkshire fitting. These are pre-soldered for you, so you have to clean them, add the flux, and when you add the heat, the solder will run out through the joint, securing it in place. These again come in various sizes, T-piece, elbow, and various different T-shapes depending on your job. They are all relatively easy to use. All you have to do is add heat. If you can't or don't want to use heat, then you can use compression fittings. A compression fitting compresses an olive into the joint between the nut and the fitting itself. The olive gets put in place, the nut goes into place over the top, put the pipe in between, and the olive is compressed between the pipe and the fitting, closing the seal. Again, they come in different sizes, 22mm elbows, T-pieces, and straight connectors. This is called speed or push fitting. Very simple. You undo the joint, push the pipe in, close it tight, and the joint is sealed. Different types of fitting are 22mm T, 22 to 15mm branch, 22mm straight connector, and there are other various adaptations you can also use. The copper joints are solder joints. They will last for as long as the copper pipe does, and these should be used where you cannot gain access easily. The compression fittings and speed fit fittings should only be used where you can gain access, because they will require maintenance. They should not be used behind walls or under floors. The first thing we will demonstrate is an end feed capillary fitting. This is the most common fitting, mainly due to the fact that they're much cheaper than the alternatives and give a strong join. To begin, hold in the vise. If you don't have a vise, then you must use a heat-proof surface. Never solder without the proper protection. Use a cleaning tool for copper pipes set to 15mm or 22mm. These are freely available from any plumber's merchant or DIY shop. Alternatively, you can use wire wool. The active flux prevents any further oxidization and also acts as a lubricant for the solder to run around the fitting by capillary traction. The solder you use has to be lead-free. This is because it's a water source, so the pipe must not contain lead. For the demonstration, we will be using a trigger-operated gas torch. There are other torches on the market. Any blowtorch will do. Trigger-operated torches are more expensive, but they give you more control over the flame. You must use propane gas for soldering. We will show you how to prepare this torch, but you should follow any instructions with safety guidelines included with your own. You must check to make sure the power button is set to off, and the gas nozzle is also switched off. Check the threads for damage, and check the threads on your gas bottle. Then screw the bottle gently into the torch, hand tight only. Smell the joint to make sure there is no gas escaping. If there's no smell of gas, then you have a good seal. If there is a smell of gas, you need to replace the bottle or the torch accordingly. Switch the torch on, switch the gas on, and the torch is now operated by the trigger. You must clean up all the bits of pipe. All the surfaces to join must be cleaned. Some of these jobs can be done prior to fitting, but if you must join the pipes in situ, make sure that you put a heat-proof background behind the pipe so as to reduce the risk of fire. Once all surfaces are clean, you must apply the flux. This must be applied to all the joins inside and outside the pipes. The joint is now ready for soldering. The blowtorch will bring the copper up to temperature. The solder will melt from the heat of the copper. Do not melt the solder with the flame. So when you're adding the solder, the torch must be off, otherwise you melt the solder before it's in the joint. Move the flame across left to right, adding the solder as you go. Test the joint with the solder. If it's not hot enough, then continue to apply the flame. Push about 10mm of solder into each joint. You must look for a silver ring all the way around each join. When you see this silver ring, there is enough solder in the join and it's secure. When you finish soldering, you must ensure that you turn the gas torch off. Once you've finished, leave it to cool for a few minutes. Always proceed with caution to prevent burning. Excess flux around the joints will cause brown spotting. Take a slightly damp cloth and wipe over the joints, removing all excess flux. Otherwise the pipe will turn green. With a solder ring fitting, you must do the same as before, except you do not have to add the solder as it's already been applied for you. So, as before, make sure all the pipe ends are clean. You must still remember to add flux to help the solder run around the joint and to prevent oxidization. This time, you do not need to add solder, so you apply heat to the join and wait for a solder ring to appear at the join ends. A solder ring fitting is 3 times the price of an end feed piece. But for people who have little experience in DIY, the solder ring fitting is an easier way to join copper pipes. It is important to ensure that the join has cooled sufficiently before handling it, otherwise the join can crack. If it cracks, then you must discard the joint and start again. We will now show you compression fittings. For this, you will need an adjustable spanner. To help with a good seal on a compression fitting, we recommend you use PTFE tape or a joining compound on the end of the pipe. It's preferable to use PTFE tape because it's easy to use and will help gain a good seal. It is simply a white tape that you wrap around the end of the pipe, usually about 2 turns worth. Once applied, push the end into the join, forming a tight seal. Bring up the olive, and then the nut. Tighten the nut firmly with your fingers, and then tighten with your spanner. Be careful not to over-tighten because it will crush the olive and you will see it begin to appear under the nut. This means it's being crushed and not compressed. If this happens, you must break the joint, add some more PTFE tape, replace the olive and start again. If you crush the pipe, then you must replace it. This is the speed fit or push fit connection and it's very simple to use. You simply loosen the connector, slip the pipe in, pushing firmly, and hand tighten. This is a very easy method, but also a very expensive one. It's also a very large fitting compared to the copper and would not be suitable for tight places or behind walls or under floors. For this section you will require solvent cement, wire wool, a hacksaw or a specialized plastic pipe cutter, and UPVC trichloethylene solvent cleaner. Plastic pipework is used primarily for waste and pipework which is on show. You should always use plastic pipes for your sink, bath, and toilet wastage. In this demonstration, we will show you how to simply join 2 pieces of straight pipe together. However, this technique can be used for joining any types of plastic pipe. To do this, you need to either use solvent cement, which is similar to welding, or you can use a compression fitting. We will show you how to do a solvent weld. If you look carefully at your plastic pipe, you will see it has a natural sheen on it. You have to remove this, and the best way is to use wire wool. To cut plastic pipe, the cheapest method is a hacksaw. This is a difficult method to get a good straight edge, and when you are solvent welding, you do need to make sure you have a good straight edge. You can, however, get a specialized plastic pipe cutter. This operates on a wheel, which clamps onto the pipe, cutting the groove, giving a nice straight edge. The release mechanism at the bottom allows you to adjust the cutter to up to 75mm pipe. Line the cutter up with the pipe and tighten the wheel firmly. Be careful not to crush the pipe. As you turn the cutter round, you must turn the wheel at the bottom after every 2 or 3 turns to move the blade further in. Continue to do this until the pipe is cut. Similar to copper pipes, you must clean the inside and the outside of the pipe where the join will be with wire wool, making sure you take off the sheen on the outside of the pipe. Then you need to clean it using the UPVC solvent cleaner and a cloth. Wipe it around the surface you've just cleaned with the wire wool. This makes the surface spotlessly clean and will make the solvent weld a lot quicker. Solvent cement is not glue. It actually fuses the 2 plastics together. You must use this only in well-ventilated areas. Coat both surfaces in solvent cement. Push them together and twist to make sure that the solvent spreads around the joint. Once the pipes are joined, they must be left and put under no stress for at least 25 minutes. After this time, the pieces are as solid as a normal piece of pipe. There are many different pieces and sizes available. T-pieces, elbows, 45-degree and 90-degree angular. You would normally use 1 1/4 inch on basin waste and 1 1/2 inch on bath waste. If you're not happy with solvent welding, then you can use compression fittings. Compression fittings again come in all the various different shapes and sizes, straight connectors, elbows and T's. The one demonstrated is a 1 1/2 to 1 1/4 inch reducer. The way these work are very similar to the copper. You have the nut, plastic compression ring and a rubber sealing ring. When fitting to the pipe, you must put the nut on first, then the compression ring, and then the sealing ring. The sealing ring has got a tapered edge. You must put the tapered edge towards the fitting. Bring the fitting in, push up so the tapered edge is squeezing onto the fitting. Bring up the compression nut and you hand tighten only. The reason for this is because the join will never be under pressure. On the other side, you must repeat the process. You must put the nut on first, then the compression ring, then the sealing ring. This section will show you the various wastage traps that can be used on sinks and baths. All baths and sinks should have these traps fitted to them because they collect debris and help to prevent the pipes from becoming blocked. All of these are available from local plumbers merchants. One of the traps that you can fit onto a basin is called a bottle trap. This part fits onto the waste end of the basin, and this part is where the waste runs down and joins the main stack. This bottom part is the bottle trap, which is where the debris is collected. You should clean this out every so often. Ideally, these are used on a pedestal basin because it sits nicely behind the pedestal. These are also available in chrome. The other type of trap you can use for a basin is an S trap. This end attaches to the waste and water runs off in an S. These are adjustable and will twist in the middle. It will do the same job, but allow for tighter gaps. This pipe is the down pipe, which lets the water go down into the waste. If you want to go straight out through the wall, at this point it will come round and go straight out through the wall. This is called a P-trap, and it will do exactly the same job with exactly the same amount of flexibility. This is called a shallow bath trap. It is not as deep as a basin trap. A basin trap needs to be a minimum of 75 millimeters deep because of the shape of the appliance. A bath trap, however, can be shallow, a minimum of 50 millimeters deep. It's important to reseal the trap when you empty it, because there's no water in this part. Drain smells may come up through the trap and into the bathroom. On some of these, there is a pipe at the bottom. This is an access eye to clean out the bottom of the trap without having to take it off the appliance. This is a 1 1/4 inch slotted basin waste. The slots are designed to meet up with the overflow that is built into a wash basin. The flat steel area is where you add a sealing compound to seal it to the appliance. It goes through the hole in the basin, a polythene washer comes up underneath the basin, and then you tighten up the locking washer. This is a waste point for a bath. It comes in a complete set with a bath wastage overflow as one. On our demo model, there's a soft fibre washer already on the underside, which means you don't have to use a sealing compound. This comes in conjunction with what fits underneath the bath. So when the two come together with the bath between, they then form a seal. These are held together on the top of the bath with a screw, which when tightened, forms the seal. There will be instructions included with any parts that you buy, and you should follow these instructions using this DVD as a guide. Above the plug point is the overflow point, which is 3 separate parts. The part that the overflow connects to, a soft rubber washer, and the overflow connection, nice and shiny because it goes on the outside of the bath. Bring the two together with the rubber seal on the bath side and hand tighten only, forming a seal. These come in different sizes, depending on the size of the hole in the overflow point of your bath, so make sure you look and buy the one you need. So now that you have your two pieces in position, you must join the two pipes at the back of the bath with a flexible overflow pipe. This is a standard fit which will just push on to both ends. The bath trap connects directly onto the bottom of this, hand tighten only. The waste then runs away at the back, out through the wall or down through the main stack. You slot your basin waste pipe through the basin and attach it in exactly the same way. It is imperative with any waste fittings that you ensure the rubber seal is in place. This hand tightens only into place. The waste can either go down or through the wall into the main stack pipe. This is a standard WC pan connector which connects your toilet to the main waste stack. It can go in this position, or straight down. The one demonstrated is a standard 90-degree bend. You can also get straight ones, and these can be cut and modified. There are various shapes and sizes for the feeder to tap into. Ask your local plumber's merchant and they will give you any advice you need. If you cannot make a connection when you change the angle of the WC, there are flexible fittings available, but these should only be used as a last resort because they have a serrated edge. A smooth bore is always better than flexi fitting. However, this will allow you to get around any difficulties that you may come across. If you have problems fitting a new bath waste to an old pipe, this again is a flexi fitting to get you around any slight angles. It is a compression fitting, exactly the same as before, but again, you should try and avoid using serrated edges because it affects the flow of the water. This section will show you the various types of taps and how to connect them to sinks and baths. This is intended only as a guide, as taps come in various different shapes and sizes and will contain individual instructions which should be followed. We will also learn how to check our taps for leaks and drips. For this you will need a flat-headed screwdriver. This is a basin tap because it has a 15mm thread. Bath taps look exactly the same, but with a 22mm thread. On the underside, you attach a washer and then a back nut. This tightens up and holds the tap in position. Pointing up, always make sure the contact is on the right. Bath taps come in various shapes and sizes. This is a standard 22mm mixer, cold on the right and hot on the left. The water is actually mixed in the spout, not in the body. Again, fixed to the bath in the same way, it's nice and flat at the bottom. Our demo model has a rubber washer, which goes on top of the appliance to form a seal, and the back nut screws up, sealing it to the appliance. On the end of taps you have some form of filter or diffuser. When you're fitting new pipelines, make sure you take these out when you flush the system for the first time, because it will collect all the dirt and rubbish lying in the pipeline and will stop the water flowing properly. Using a screwdriver, simply pop it out. Some other more expensive versions will have a screw which needs to be unscrewed. The same applies for bath taps as well. This is an isolation or service valve which needs to be fitted under the basin on the hot and cold water pipes and the WC cold water feed. On the center is a screw, and inside is a ball valve. When the screw is in the upright position, as it is now, the valve is open. When the screw is across, the valve is closed. These do not need to be fixed to the bath taps. If they're not already on there, it is a gravity-fed system. You cannot fit these to your cold and hot water feed for the bath because they're 22mm. Underneath the unit, to connect the pipe in, we use what's called a tap connector. This one is a straight connector. On the head is a fibre washer that joins up with the tap and tightens up. Make sure the fibre washer causes the seal by using a spanner. This part here is a standard 15mm compression nut. You don't always have to use straight tap connectors. There are others available. Another type of connector available is a 90-degree angle connector with a built-in service valve. Once again, a fibre washer creates the seal, and with the tap in that position, you can still gain access to the service valve and isolate the tap. It is important that you can gain access to the service valves, and when screwing in the taps, make sure it is in the position with the easiest access. All the fittings we have just shown you are also available in 22mm. To save you connecting up to the back of the basin, which can be quite tricky, you You can use a flexi pipe with a built-in service valve at the end. The top end attaches to the tap, and the bottom end is a standard 15mm compression nut. On the top end is a rubber sealant washer, which tightens up onto the tap with a spanner, and the opposite end is the isolator valve, giving you room to move about freely, meaning that you don't have to be as precise with your pipe work. These are ideally used behind a pedestal basin, or if you're going to put in a vanity unit and you can't see it. They come in different lengths: 300mm, like the one demonstrated, 400, 500, 600, all the way up to 1.2 meters, helping you around a variety of problems. They also come in 22mm, but make sure that you're allowed to fit them. If you notice your taps are starting to leak at all, it is relatively simple to repair. If you have a drip from here, this would suggest that the washer has worn out. If there is dripping from there, this means the rubber olive has worn on the inside. Underneath the tap will be some form of isolation. Locate this and isolate the tap before you do anything. It is a good idea at this point to put the plug in the sink to stop any parts falling down the drain. Gently prise the top of the tap off. Inside you will see a screw. Remove this gently. Lift the head of the tap off and take off the headgear using an adjustable spanner. Some of the washers have screws on the end, but they will all come off easily. Prise the washer out and replace it with a new one. At this point, we recommend that you change the olive as well, because it will save you having to carry out this process twice in a short amount of time. Check the seating on the inside of the tap. There's a shiny brass ring on the inside of the tap, and that is the tap seat. If the tap seat is worn or is pitted, the tap will not seat properly. To reseat this, you will need a tap reseating tool, as shown on screen. This red bit has different threads on it. There are normally 2 in a pack with 14 threads, and this will centralize the spindle. Line it up on the tap using just your fingers. Turn it 6 times, and then undo it again. Check the seat is nice and shiny and flat. Reinsert the headgear, hold the tap, and nip it tight with a spanner. Put the head back on, and put the cap back on. Re-enable the water supply underneath and test the tap to see if it works properly. This section will show you all the various types of flushing systems that can be fitted in your toilet system. This is again only intended as a guide. We would recommend following the instructions included with the system. These are all available at local plumbers merchants. For this section you'll require water pump pliers, a standard 5-inch adjustable spanner, a standard 12-inch adjustable spanner, a medium flathead screwdriver. The older type of common cistern used to come with a side flushing handle. This is the type of device that would be inside it. As you pull the flush, water is released. A siphon is caused and the cistern will flush. Cisterns have moved on since then. This is a side water inlet. We've removed the ball so you can see it. This is your standard float arm, stopping the water in there. You would need a large cistern to fit both of those in. Cisterns are now getting smaller and moving to parliamentary. This is a Tormeg equilibrium valve with a silencer tube on the side. It fills up from the bottom, so you can't hear it filling up with water. The float arm is there. Inside there is an equilibrium valve. The water pressure acts on the washer side, closing it off using the pressure available. The same thing is also available inside entry, smaller and smaller to allow for more cisterns. Water regulations now state that you're only allowed a 6-litre flush. The equilibrium valve has now progressed. This is the equilibrium valve. The valve system is now there at the top, and the lever principle has changed. Here is the float cup and the equilibrium valve at the top. This is built on the same principle. Float cup at the bottom and equilibrium valve at the top. Bottom fed, so the water also comes out from the bottom. Moving away from a standard flushing device, this is designed for push button. You press the button on top, it lifts a valve in the base, the water will release, holding the valve open till the water level drops. The valve closes once the water has gone, only allowing 6 litres of water to flush. All modern valves have a built-in overflow, so there is now no need to have an overflow running out of the side and out through the wall. If there is a problem, you might see a constant flow of water running down the back of the pan. Here's one of the simple versions again. It's designed for push button. From the top, a button comes down, the lever is lifted, and the same thing happens. The overflow is built down in the center of the system. This one is pneumatic. This is a piston with a tube between it, bellows, and a lifting arm. But the principle is exactly the same as the bottom. You press the piston, it pushes air into the bellows, lifting the valve, again resulting in the same effect. Often these are placed against the wall or on the floor, or for people with disabilities who cannot turn around easily. It is advisable that you buy a complete set and follow the instructions. Before you attach the flushing system, if you look at the bottom, this is where the bottom water feed will go in. So we need to make sure the overflow pipe is facing the opposite side. We also need to make sure that the rubber washer is in place on the bottom of the cistern. Slot it in position and hand tighten the nut on the bottom. Make sure it's in position and then tighten with a spanner, making sure the rubber seal is nice and tight. We need to add the flushing system. First, we must remove the float arm so it does not get damaged. This simply just pops off. When you fit the overflow pipe, make sure you line it up properly so that when you connect the float arm back up, it has room to operate. Keeping the washer on the inside of the cistern, push it through the hole. Lay the cistern down and hand tighten the nut onto the bottom. Then use the large adjustable spanner to tighten, holding the cistern to make sure it doesn't turn. Now you need to add the float arm again, simply by popping it back into position. Move it around a few times to test that it operates freely. Now we're going to attach the cistern to the pan. You'll need the rubber donut washer and 2 fixing clamps with rubber sealing washers on. These will go through the cistern, through the 2 holes on the pan, and clamp into position. If your instructions tell you to put the donut ring over the gap on the pan, do not do this, because when you lift the cistern into position, it's very easy for the ring to slip or move, and therefore the seal will not be fully secure, resulting in water spraying out of the back when you flush. So fit the donut ring on the cistern as shown. Then lift the cistern and line up with the hole, then lower into position. Hold it in position and line up the 2 smaller holes where your fixing clamps will go. Slot the fixing screws through and hand tighten. Then take your flathead screwdriver and tighten from the inside of the cistern. Connect the WC to the main waste stack. You must fit the pipe in as shown. Making sure all rims are firmly in place, push the pan into position and the seal is created. This section will now talk you through how to install a bathroom suite using the techniques you've been shown before. Before you start working in the bathroom, you must turn the main water supply off. If you're in any doubt, you must locate the tap that looks like this. This is your mains inlet stop valve. If you turn this off, you will stop all water coming into your house. In the airing cupboard, there will be 2 22mm gate valves. One is for the hot water, which comes from the cylinder. The other one is from the cold water tank. Turning both of these off will isolate the hot and cold water to the bathroom. You must determine the height of the bath panel. Any bath height is determined by the height of the panel that comes with the bath. Draw a corresponding mark on the wall. Because no floor is ever level, from the first mark you use a spirit level. Once level with the mark, draw a line around the back of the wall, making sure it is level all the way around using a spirit level. This line is here to help determine where the supports will go to help support the bath. On the demonstrated floor, we have solid one-sheet plywood on top of the floorboards, so we don't need any support underneath. If, however, you're going to install the bath on top of floorboards running horizontally under where the bath will be, then you need to help support the bath. Some baths come with wood already fixed in place, and the brackets to help fit it to the wall. If it is an older type bath, like the one in our demonstration, then you need to help support the weight of the bath. 1 litre of water weighs 1 kilogram, so a full bath, plus a person, plus the weight of the bath, is an incredible amount of pressure to put on the small surface area of the legs. Therefore, we need to help disperse that weight by spreading it across the floor, and by supporting it on the wall. To do that, we drew this line, to fix 2x2 battens along the back wall and at the opposite end to the taps. Do not fix a batten at the tap end, or you will not be able to fit the taps properly. This batten will help to support the weight between the wall and the floor. Always try to dress the bath before you put it into position. It makes it easier to get things lined up before you fit the bath in place. On the bottom of the taps is the rubber washer, or in some cases a small fibre washer, depending on how expensive the taps are. All the instructions will show you exactly how the taps are fitted. So, we feed the pipes through the holes, and the rubber washer will cause the seal. On the back, you must then put the back nuts on and hand tighten them. On screen is a tap spanner. One end is 3/4 inch for bath taps, and the other end is 1/2 inch for basin taps. Take a firm grip at one end. The other end turns around as demonstrated for tightening up, or if you take the end off and turn it around, it will loosen the joint. As demonstrated, it simply locks around the joint. Make sure the taps are firmly screwed in. We will now fit the bath wastage drain. As shown before, the rubber washer will go here and be centralized. Make sure the overflow points towards the back, in line with the taps. Now carefully put the plug hole over the top on the other side of the bath, and using your hand, start to screw it into place. Once the screw is joined enough to let go of the rubber washer, use your screwdriver to tighten the screw. Make sure the unit is centralized when tightening, so that it doesn't move. The nut and the bolt are held together by plastic, so be careful not to over-tighten, or you may pull the bolt through the plastic. We will now attach the overflow. This goes on the outside, and the metal part goes on the inside. Meet the two together and hand tighten, and then add the overflow flexi pipe. Whilst the bath is in this position, we add the tap connectors because it makes it easier to get them tight. Once they're in position, make them nice and tight using an adjustable spanner. Finally, we fit our bath trap. Make sure the rubber washer is in position. Line it up with the waste drain. Hand tighten, making sure that the threads do not cross. This is most important because if you do get a cross thread, it will leak. The bath is now ready to go in place. The bath must be level in both planes. To do this, take one of the legs and use that as a dating point. We will level this leg with its opposite, and then level these two legs with the other two. On the bottom of each leg is a screw point, and inside these is a thread. So by tightening or loosening these threads, we can adjust the height of the leg. Using a spirit level, adjust these until the bath is level. Using plumber's mate putty by rolling it in your hands, smear a very small amount onto the bottom of the taps and squeeze them into the sinkholes. Put the washers and the back nuts in. To make sure these are nice and tight, use a tap spanner again, or a box spanner, like the one here, which fits over the nut. Tighten as tight as you can and use a screwdriver or Tommy bar through the hole at the top to nip it tight. Then, using a screwdriver around the top of the taps, remove the excess putty gently. Add the putty around the underside of the wastage drain. Slot it into the sink, making sure the two wastage drains face back and front and not side to side, so they're in line with the overflow. Squeeze it in, add the washer on the other side, then the nut, and then tighten using an adjustable spanner. Remove any plumber's mate putty by using a screwdriver. The bolts are already in position. There are two types of basin you can get, some with brackets that come out of the wall and the sink then sits on the brackets. The sink is bolted to the wall and the pedestal supports the basin. With this one, you have a mushroom washer and a nut. The basin goes on the wall, the mushroom washer in that position, and then the nut will feed in behind it. Once in position, using your 5-inch adjustable spanner, tighten the nuts up. The holes at the back of the sink are big enough so that if you need to adjust the level of your sink, you can loosen the nut, move the sink into position, and then tighten them up again. These are pipe clips. Attach a screw and fix it to the wall. The center line is exactly where the screw edge should be. Once you've finished the job, close the top over and it will hold the pipe firmly in place. Always put your pipe clips in first, before you start to fix pipes together. Holding the pipes level as shown, mark directly above the pipe. We will now use our 22mm pipe cutter. This one is slightly different to the one shown before. The other one had a clamp over the top. On this model, you push the pipe in, leading with the rollers, and turn as shown. There is an arrow on the side to show this. Line up the center line with the mark you made on the pipe, and turn. Join the pipes using the joiner, and they will need to sit at the level shown. At this point, we need to fit a different fitting. This is similar to an elbow. It has a male and female end. Connect as shown, allowing you to twist so you can angle the pipe up or down. That's the start point as shown. The pipe is connected to the tap connector. This is the cold feed here, and this is the cold feed coming from the airing cupboard. That is now our first piece of pipe ready to go. So, we line it up in the clips, slide it across until it meets the joint. We can now see the end of the socket. You now need to mark the pipe where it will join. You then need to remove the pipe from the clips again and cut the pipe where you marked it. Clip the pipe back in, slide up to the join, and meet them up. We will use a push-fit T and the drain off. If you need to drain off the pipe for any reason, then attach a hose to this point and turn the valve. You must try to keep the tap connector pipes as close to the wastage pipes as possible, keeping it nice and tidy. You need to measure from the wall to the line on the fitting. You must take off 10mm because the back of the clip is 10mm wide. You need to try and avoid soldering tight corners. Measuring from the right end, check it twice and then bend the pipe as shown before. Clip the newly bent pipe into the wall. Put your spirit level in line with where you want the pipes to come down. On the T-piece there are 3 ridges where the pipelines go into, so we will draw a line on the T-piece on the centre point there. We will mark the copper pipe at the same point, and that is where we will cut it. You need to line up the T-piece with the copper pipe, underneath where you want the pipes to run under the sink, and mark the copper pipe for cutting. Once you've cut the copper pipe, connect the pipes up as shown before. This is the cold water pipe we fitted earlier. This one has been soldered together. This is 22mm feeding into the cold tap. You can see where it's coming from the airing cupboard, which in turn is coming from the tanks in the loft. Therefore it is gravity fed, so you need a 22mm pipe to get the right flow of water into the taps. There is no isolator valve on this pipeline. To turn the water off, you must go to the airing cupboard and turn the red-handled valve. Notice that the cold water is under the hot water. This is so the hot pipe doesn't heat up the cold water. The pipes run along the side of the bath along the wooden support, otherwise they might rattle. When we get to the corner, we have bent the pipe, remembering it is important to bend wherever possible because the flow rate is better than when a joint is soldered. This also means less soldering for you. The less fittings you have means less soldering, which means you spend less money. Coming around, this is the cold pipe here, which comes up on the right-hand side. Here is the flexi pipe underneath to ease connection to the taps. There's a small crossover here to get over the hot pipe. You should try to go behind the waste pipe, but due to lack of space, we've been unable to here. This then runs along, bends up onto a flexi pipe from the WC. Notice the 3 isolator valves. The hot pipe is very similar. It comes again from under the bath and is on the left-hand side. It runs along the top to the drain-off point, then follows around behind the cold, crosses over the waste pipe, up and into the flexi pipe. Once we have the system running, it must be tested. It can be air tested, but this can be quite expensive. If you know where the water is coming in and going out, then you should test with water, as water will always come through. Turn on the tap in the basin and leave it running. Look inside the basin and around the rim, where you formed the seal with the plumber's mate, and check it to make sure it's tightly sealed. Leaving the water running, check underneath. If there is any seepage, then you will need to seal it again. Open the isolator valve connected to the WC to let the water in. Kitchen sink waste is exactly the same as the waste of a bath. There is a soft fibre washer on the underside and a pipe for the overflow, held together in the centre by a screw. Put the drainage plug on top and the underside underneath as before, and screw into place. Fit the overflow pipe and screw the overflow piece in, remembering the overflow pipe, the taps, the flexi pipes and the wastage trap. This is a standard wastage trap. This is a blank end for food processors or similar appliances to use for wastage. This end is for attaching dishwashers or washing machines. All modern appliances have single feed appliance. The main pipe then feeds through the wall and out into the main wastage. By following all of these stages, you should now have a bath and a sink with hot and cold running water and a toilet that flushes. By using the techniques and stages demonstrated in this DVD, you should find you can now take on pretty much any basic plumbing project. Remember to check and prepare your appliances accordingly by following the stages we've taken you through. We hope you've enjoyed this tutorial DVD. There are a wide range of other DVDs available in the Able Skills series of tutorial DVDs, and Able Skills also offer a wide range of 5-day intensive and City and Guild courses for a number of specialist areas. For more information or to book a course, please visit www.ableskills.co.uk or contact one of our staff today on 0808 100 3245. All the tools used on this DVD are available on the Able Tools website at www.abletools.co.uk. Welcome to Able Skills, a City and Guilds NIC, EIC and EAL approved training centre. We now offer courses to suit everyone with an interest in building, from enthusiastic DIYers through to experienced tradesmen or women looking to learn an additional skill or to refine their techniques on one of our advanced courses. Are you looking to learn new skills in building? Maybe for that DIY project that you've been putting off? Maybe to use the skills in your existing trade or to start a new one? Whatever your reason, courses with Able Skills will give you the start you need. Our courses get you using the tools and developing the skills right from the start, under the careful guidance of our instructors, who all have years of experience in their trades and who are NVQ, City and Guilds, CITB accredited, and who are assessors in their own right. With our small training group sizes, you can get all the practical advice and personal attention you need to master each task and build your confidence. The friendly group atmosphere on our courses helps everyone to feel at ease, even if you are a complete novice. At our new, spacious centre in Dartford, Kent, you can learn or improve your skills in plumbing, brickwork, plastering, tiling, and electrical installation. Our plumbing course will show you what to do to tackle everyday plumbing tasks and emergency repairs around the house, avoiding you having to pay someone else and saving you money. The course covers subjects from fitting a simple washer, laying and bending copper pipes, how to use push-fit plastic pipe for hot and cold services, pressure testing, fitting and soldering joints, preparing pipework, fitting complete bathroom suites, baths, sinks, showers, and toilets, including running waste systems from each. You will also have an understanding of running pipework for central heating systems, running hot and cold water to your combi boiler, and fitting radiators, changing tanks and cylinders, replacing motorized valves for heating and hot water systems, running the flow and return to the radiators from the boiler, and fit taps to sinks. This course is designed to give you training in everyday plumbing and covers changes to building regulations, therefore also advising you of changes to existing plumbing methods. Training on heating systems contains details on energy saving and other environmental and money-saving issues. We demonstrate and teach about all existing and new plumbing materials. With skills, you will have the confidence to take on everyday projects around the house and develop your expertise. We also offer an advanced plumbing course, which is designed to teach you how to carry out plumbing installations around the house. You will be taught how to fit or replace cold water tanks and fit or replace hot water cylinders. We will show you how to run hot and cold services from the loft to the bathroom and kitchen. The course also demonstrates how to fit central heating flow and return pipes from the boiler to the radiators, fitting central heating pumps and motorized valves, and how to run pipework to a combi boiler. The course content also covers use of water filters and conditioners, and awareness of water bylaws. We will explain how to alter soil pipes and how to clear blockages on drains, waste pipes, and guttering. Plastering is one of those skills which many people, including competent DIYers, shy away from, preferring to call in a professional at considerable expense. That's fine for major jobs, and if you can afford it. But why not see what you can do for yourself, whether this is for your own project or maybe for a career change? You will learn how to cut and fix plasterboard to walls and ceilings, to cut and fix angle beads, to tape joints, and how to prepare surfaces before plastering. You will be shown how to use bonding and finishing plaster, ensuring a flat surface for decorating. We will teach you how to skim walls and ceilings. You will also be taught how to repair damaged plaster, and also how to render external walls using sand and cement. We try to cover every aspect of plastering that we can, and feel confident that after spending time with us, you will be ready to tackle everyday plastering requirements. The atmosphere is pleasant and encouraging, and people generally find the time spent with us to be an enjoyable one. We now also offer an advanced plastering course for people looking to increase their speed and technique. This course concentrates on cutting and setting beads, bonding, skimming, and also repair work. This is available over 5 days or 2 weekends. If you have some plastering knowledge, why not try our 2-day skimming course set over a single weekend? This course concentrates solely on skimming techniques. Tools and equipment will be fully supplied, explained, and demonstrated. Able Skills Tiling course is designed to offer you a good understanding of the practical skills involved in tiling. We will demonstrate and explain how to set out your tiling job. We will take you through floor tiling, wall tiling, tiling work surfaces, tiling splashbacks, and explain the different adhesives used. We will show you all the ways of cutting tiles using wet tile cutters, dry tile cutters, tile scribes, tile snips, and tile saws. We will demonstrate decorative tiling involving borders, diamonds and patterns, and also show you how to cut around windows and reveals. We will teach you to cope with tiling difficult areas, around sinks, electrical sockets, and boxed-in pipes. You will also learn how to grout and polish, and how to use silicone sealants. We will cover every aspect of tiling, and we feel confident that after spending time with us, you will be ready to tackle everyday tiling requirements. Whether you're planning to do your own bathroom or kitchen, or looking at tiling as a possible career. Either way, this course has a lot to offer you. In addition, we also offer an advanced tiling course which builds upon the knowledge gained on our intensive course. You will be taught how to deal with even more difficult obstacles such as shower attachments, tiling behind existing sink pedestals, behind radiators, and around toilet waste soil pipes. We aim to improve your speed and precision, at the same time incorporating different materials, including mosaics. We also demonstrate the correct procedure required when you need to remove and replace existing damaged tiles with new ones. All the tools and equipment you need are supplied, explained, and demonstrated with an emphasis on safe and efficient practice. As on all our courses, trained instructors with a wealth of practical knowledge and experience gained in the trade are there to answer any questions, show you the proper techniques if you get stuck, and generally to encourage you. This way you learn faster and grow in confidence in your skills as the days progress. Welcome to Able Skills Bricklaying course. On our bricklaying course, you will learn to set out building lines, to use bricks as well as blocks, how to ensure your walls are square and vertical, how to build a corner, a pillar, and a cavity wall. Also, you will learn the different types of bricklaying bonds, and be shown how to do pointing for facework. We will demonstrate how to put in a damp course, and how to put in lintels and windows. This course is designed to provide you with plenty of general building knowledge to ensure that when you leave the training centre, you are confident in all areas of brickwork. The course fee of £300 will soon repay itself in all the highly practical and enjoyable jobs you will be equipped to take on. Able Skills also offers an advanced bricklaying course which will teach you how to build more ornate brickwork with finesse. We will show you how to angle bricks by cutting them with different tools so that you can create an even joint throughout that piece of work. You will be shown how to build archways, conservatory bases, swoops, ornate pillars, bird's beak detail, soldier course, spiral pillars, and fireplaces. The course is also suitable for ground workers looking to build boxes and manholes. Able Skills is happy to advise you on any building project you are undertaking if you bring your plans or drawings along. Kitchen fitter or gas installer that in the past has always carried out your own electrical work, but under the latest government legislation have had to stop? Have you been carrying out electrical installation work but do not have a recognised electrical qualification? Or maybe you are looking to start a new career in the electrical industry? At Able Skills, we can now deliver the VRQ Level 2 Domestic Electrical Installers Certificate. This gives candidates a nationally recognised electrical qualification, allowing them to become a qualified supervisor of firms that are registered with approved Part P competent person schemes. In our newly fitted out electrical training area, you will be shown how to use the latest Part P approved test equipment and carry out fault finding on our test rigs. The courses are demanding and intensive, but under the careful guidance of our highly qualified instructors, using our small class sizes and fully trained assessors and verifiers, you will get all the practical and technical advice that you will need to master each of the 17 modules and build your confidence. Once successfully completed, the holder will be able to apply to register on the Domestic Installers Scheme, and on acceptance, will be able to install, test, and self-certificate their own work. We are also offering a 2-day course for candidates who have a limited knowledge and want to improve their electrical skills to allow them to go on to the 5-day VRQ2 course. In addition, to meet the minimum requirements of the building regulations, all those carrying out domestic electrical installations need only to achieve Unit 1 of the VRQ. Applicable Building Regulations for Domestic Electrical Installation. This provides the understanding of the requirements of the building regulations which are relevant to organisations undertaking domestic electrical installation. This is a 1-day intensive course for qualified electricians only. Why not try Able Skills Multi-Skills course, which enables you to train in the 4 courses of plastering, plumbing, tiling, and bricklaying. Or maybe you would choose to train in 2 or 3 subjects and then include an advanced option. Whatever your aim, Able Skills will arrange these courses to suit you. You can train in a 4-week block, or you can spread these courses over a longer period to accommodate your existing commitments. There is now a greater demand for people to be multi-skilled in their work. Companies seem to prefer to employ people with knowledge in several areas, so the multi-skilled option may suit you if you are looking for a career in this area. Able Skills can now offer you a 6-week training course in any of our subjects, which will provide you with an entry-level City and Guilds qualification. Able Skills is a City and Guilds approved centre and offers qualifications in the following. Plumbing 6129, Level 2 Technical Certificate, the recognised entry requirement to the plumbing industry, and NVQ 6089. We also provide qualifications in carpentry, plastering, bricklaying, and tiling. Additional electrical qualifications we offer are City and Guilds 2381, 2391, 2377 and 2330 Electrotechnical Certificate. Other qualifications available are the BPEC Water Regulations Certificate covering current legislation, BPEC Unvented Hot Water Systems, and also Energy Efficiency for Domestic Heating Systems. On our City and Guilds courses, we offer you the chance to train at weekends and the option to pay as you train. This will be at no extra cost to yourself. Able Skills is the only private training facility in the UK able to provide all of these recognised qualifications. Further details on these can be obtained by contacting the staff at Able Skills. Our position, just south of the QE2 bridge on the M25, makes us easy to get to, with suitable parking available. Rail links are excellent too, with connections from Charing Cross, Cannon Street, Victoria and London Bridge direct to Dartford Station, which is just a 5-minute walk from the centre. We donate £1 to Great Ormond Street Hospital Children's Charity for every course booked. If weekdays are unsuitable due to work commitments, we do offer most courses split over 2 consecutive weekends for convenience. Course content remains the same, with 5 days condensed into 4. In all courses, you will be involved at every stage and will be participating throughout. It is therefore recommended that you bring suitable clothing, and for your own safety, steel toe-capped footwear is essential. After you have trained with us, we are happy for you to contact the centre at any time by phone or email, should you need clarification or advice on any work you're attempting. These courses are open to anyone, regardless of gender or status. Concessionary fees will also be considered for unemployed persons. If there is anything more that you would like to know, or if you want to book a course, please phone us on our free phone number 0808 100 3245. We can be contacted 7 days a week. Alternatively, visit our website www.ableskills.co.uk. Our reputation means that people are prepared to travel a long way. We can provide our own, comfortable, local accommodation on request. See our website or contact staff for details. If you are looking at new career possibilities after serving in the armed forces, we offer resettlement courses. Fax over your MOD form 1746 to 01322 280 301. Able Skills has their own tool website. If you're interested in purchasing tools, please feel free to visit www.abletools.co.uk or contact Able Skills staff on 01322 280 202.